All right, so this is a lesson we did in class on Monday or Tuesday, September 14th or 15th. So this is lesson 131. So if you missed class, this is a good video to watch just to kind of catch up. So we're talking about angle pairs with parallel lines cut by transversal, which was introduced in lesson 132. So in lesson 132, just before we get started, we talked about two lines. Blue is not the best color here. Talked about two lines that are parallel to each other. And then what's known as a transversal, which is a third line cutting through them. And the most important thing is that these two angles here, angles in a similar position, is known as corresponding. So these two angles marked in yellow correspond with each other. Also, if I went on this side, this angle correspond with each other. And so there are actually 4 pairs of corresponding angles in this drawing. The two on top of the lines on the same side, and the two below the lines on the same side. So those are the corresponding angles. And we can demonstrate they're congruent very quickly by sketching the angle on top of the angle and, and then moving that sketch down, seeing how it's exactly the same. You can either move one up to show or move it down, but either way, they're the same, and that's kind of the point there. Okay, so that was really all lesson 132 talked about. There's a little bit more there, but that's kind of the introduction. That's what you needed to retain. So if you didn't, now you know. Okay, so today, as I was just saying, parallel lines cut by transversal, we're going to investigate other special angle relationships with parallel lines cut by transversal. So let's see what we can find. Suppose we know that angle A is 48. And how do we figure out the measure of angle B? So if A is 48, and I am not writing with white anymore. A is 48. And this is where you're going to start writing on the pair deck. If A is 48, then this angle is also 48 because they correspond. And this angle and B are vertical angles. And so B must equal 48. So in other words, these two angles, which alternate back and forth across the line, are congruent. Pretty cool. It's pretty neat. So they're both 48. And so let's see what's next. Okay, A is still 48. Okay, so it's not changing. It didn't change position, so it makes sense that it wouldn't change values. So what's the measure of angle B? So with the same understanding, that one's 48 because they correspond. And this and B are a linear pair. And since they're a linear pair, meaning that they form a line together, they must add up to 180 degrees. So to find this relationship, I'm going to take 180 and minus 48, which will give me 132. And so B must be 132 degrees. So that's the idea. I'm kind of using some relationships I already know. In this case, parallel lines cut corresponding angles and linear pairs and vertical angles. Those are the two I've used so far to try to find the missing angle. So with that in mind, let's see if I'm going to put that right in the middle. It's not in the way there. Let's see if we can do the next ones on our own. Okay. So try that. Go ahead and try this next one. A is still 48, and now my picture is on top of it. We don't want that. I'm not that important. So A is still 48. What is the measure of angle B? And so, oops, too fast. And so can you figure it out? Go ahead. I'll wait. So if A is 48, this one's 48 because they're vertical angles, and this one that I just wrote down, and B, what do they do? Oh yeah, they're corresponding. And so in the same position. Oh, right, that means they're the same. Okay, so B is 48. Cool. That was exciting. Okay. And these two, notice they are on alternating sides of the line, just like that first one we kind of did. All right, let's see. Let's see what we got. So this one, now remember one of the things we said as we started this section, lesson 3, we talked about how pictures are deceiving. So A is still 48, and you're probably doing what I did when I first saw this picture. A is obtuse. How could it be 48? Remember, while they promise parallel lines are parallel and all figures are on the same piece of paper, and any markings that are put on the picture you can trust, they're not drawn to scale, and this one is clearly not drawn to scale because 48 is not that big. But we have to just kind of ignore that for a minute and trust the mathematics, okay? And so if this is 48, this one corresponds with 48. So that one's also 48 because they're corresponding angles. Can you find B? And again, I'll wait. Yep, we already did this math, 180 minus 48. And we got 132, so we've already done the math, and so B is 132 because 48 and B now are making a linear pair. And again, the picture is totally deceiving here. Be aware that CPM does this all the time. It makes me crazy. I don't like it. I mean, at least make the acute angles acute and the obtuse angles obtuse measures, but they are ridiculous. They absolutely want to force you to trust the math, not the picture. So trust the math, not your eyes, and be very aware that CPM pulls this all the time. I'm not a fan, but what are you going to do? All right, let's see what we got next. Okay, and again, I'm in the way, and now that's in the way too. All right, alternate interior angles are called alternate because they are on opposite sides of the transversal, and interior because they're both inside, that is, between the parallel lines. So these are some new words we're trying to learn, and so let me draw a picture of alternate interior angles for you. I don't know what color I'm on. Let's get back on white here. So alternate interior angles are called alternate because they are on opposite sides of the transversal. So alternate interior angles, and again, this picture is not well drawn, so I'm going to go ahead and mark those lines as parallel. And that's the real reason we don't want you to trust the pictures, is because that will force you to think, oh, I have to draw it perfectly, I have to draw it absolutely correctly, and you don't. You can draw it reasonably and then mark it so that everybody understands where you're coming from. And so I've marked these two as alternate interior angles. They are both on opposite sides of the transversal and on the interior of the two parallel lines. That's why they're called alternate interior angles. Then same side interior angles are called same side because they're on the same sides of the transversal. So in this case, right like this, same side of the transversal. And interior because they're both inside, just like these are inside, those are inside, but the difference here is these ones are on the same side and these two alternate, okay? But the lines are still parallel. Okay, let's see what we got. There it is. Think about the relationship between the measures of the alternate interior angles. Do you think they're always parallel, or are they always congruent? Are they always supplementary? So so the lines are parallel. That is really, really important. Are the angles congruent all the time or supplementary all the time? Make a decision. So remember, you're doing the paradigm as you watch this video, so pick. Okay, they are always congruent because, see, just look at sorry, if we just look at the what's happening is this angle and this angle always correspond. White is not the right color for this slide. Always correspond. And that means those two are always congruent. That's what we talked about in Friday's lesson. And so, or Thursday's lesson, depending on which class you're in. And so those are always congruent. And then these are vertical angles and they're always congruent. And you can go the other way. These are vertical angles and they're always congruent. And so these two correspond and they're always congruent. So these are always congruent. Okay, let's move on. Okay, complete the conjecture. If lines crossed by transversal are parallel. Now you can say that in a simpler way. If parallel lines are crossed by transversal, that's the same difference. Then the alternate interior angles are, again, this is multiple choice. We're choosing between congruent and supplementary. And we just answered this question on the last slide. The word is congruent for a blank here. All right, let's move on. Prove that if parallel lines are, and this they want us to use rigid motions. Okay, so if we go back to some of the stuff we learned in Math 1 with rigid motion transformations, and I'm going to use my tools to help me, my computer tools. And so I'm going to start, if I had patty paper, I would trace this on patty paper. Now, for patty paper, if you have tracing paper, like wax paper or parchment paper, both of which are used for cooking, like I use parchment paper to line my cookie sheets so the cookies don't stick, or wax paper is much cheaper than parchment paper and practically does the same thing, but it's not always great for cooking with, whereas parchment paper is designed. Parchment paper will feel almost exactly like patty paper. It just basically means it's clear enough to see through. So if we had patty paper, we would draw on patty paper, and then we would move it around until it lined up with the other angle. And so I'm going to go ahead and use my tools, and I need this one, and if you don't see it, it's this little thing right here. This one, okay, this guy right there. I don't know if I can move it. I need that guy for rotating. It's going to be a problem, but we'll deal with it when we get around to it. So for now, we'll just move this one. And then we'll go ahead and rotate it, but see how it's going to rotate around that blue thing. And I wanted to drag that to the right position, but for now we'll just do it like this, and we'll manipulate it when as we need to. And if I'd been able to put that in the right position and match it perfectly now, but same difference. The idea is that we can translate it down to EFH. So I would explain that. I can translate angle CFG. No, I went the other way. Angle BCF, I translate it down to angle EFH, and then I rotated it 180 degrees around F until around point F until it lined up with angle F, excuse me, angle CFG. And I went the wrong way, but the ideas are still good. It would be translate and then rotate until it's lined up. And it will line up every time if you draw parallel lines first, which is the hardest part of this, but it'll always line up, which is pretty cool. So that's what you're writing on this slide. And again, if I'm going too fast, feel free to pause and write things down, put things in the computer, and then, move on. Okay. So, what is the relationship between the same side interior angles? And again, your choices are supplementary or congruent. And I said that in the wrong order, but that's okay. Are the angles supplementary or congruent? Now, remember, your eyes are deceiving, and so don't use that as an idea, but think about what we could do. All right. I agree with some of you. We'll talk about it in a minute. And so complete the conjecture of lines crossed by transversal parallel and same side interior angles are. So I'm going to help you out here on this one. This angle and that angle are the same. And these two angles, F, colored gray F, and the one I drew second, those are a linear pair. And so I think they're supplementary. Okay, so my assumption is supplementary. And again, I could also use one's acute and one's obtuse, obtuse, and therefore they're not going to be congruent. So I'm going to guess supplementary. And that's always a good option for you. I don't know if you've noticed, but the angles, any two angles you pick in this picture will either be congruent or supplementary if the lines are parallel, which is pretty dang cool. So it's just a matter of remembering which is which. Okay, and so let's see what we got. So Claudio's trying to do a different kind of a proof here. Because we can't use rigid transformations because we don't think they're the same size. So rigid transformations isn't going to be very helpful here. So he's trying to prove the theorem as follows. He's lettered his angles. He's taken all the other letters off. So he's got A, B, C. And he's saying that A plus B is 180 and A is equal to C. Is he correct? So A plus B is 180 because they're a linear pair. So yes, A plus B is 180, linear pair. And so that should explain why. A and B, their sum is 180 because they add up to 1. They form a linear pair. A is equal to C, I agree as well, because they're corresponding angles. And so for yes, I think he's correct in explaining why A plus B is 180, because they are a linear pair. So I'm going to go ahead and write the words down. The reason here is linear pair. And these two angles are congruent or equal because they correspond. And remember, correspond means in the same position. Okay, so linear pair because they add up to 180 in the same position, so they correspond. Okay. Are there any questions? All right, let's see what we got here. Complete Claudio's proof that is explain why interior angles are always supplementary. So I'm going to go ahead with Claudio's proof here. And erase all the stuff I see. And get my pen on. All right. A plus B equals 180. Linear pair. I'm going to write on my face. Won't that be fun? And A equals C, corresponding angles. And here we go. I'm about to be done in a second. So since A plus B equals 180, and A equals C, I can replace A with C. So I can do substitution. C goes in for A. So it's the same statement except for that I've used substitution. replaced A with C because they're the same. And I'm done now. Because these two add up to 180, and therefore they're supplementary, and the same side interior angles are supplementary. Wasn't that a complicated, simple thing? And so that idea is really, really, really important. It's important that we know how to do that. It's annoying me that there's writing on my face. How to do that, and that it's really as easy as it seems. That is a very, very, very easy thing to say. This, and then I just plugged in. I mean, that's all that happened. Okay, let's move on and see what we have next. Oh, that's it. Okay, so that's what you missed if you weren't in class on Monday or Tuesday, and have a great day.